Okay, so let's solve this equation again. So I have x squared minus 2x plus 17. First of all, what kind of equation is this? No, that's not linear. If the x squared wasn't there, then it would be linear. What is it? Quadratic. Yeah, the formula says quadratic formula, right? So you have to have what kind of equation? Quadratic equation. All right. So those just said linear. If the x squared wasn't there, then it would be linear. All right. So what's a? So again, this is quadratic. Some of you didn't know this. That's quadratic equation. So I can solve a quadratic equation using the quadratic formula, right? So it's a. What's b? What's c? All right. So if I plug all that back into the quadratic formula, I get x equal the opposite of b. What's b?
2.
Negative 2. The opposite of negative 2 is 2. Plus or minus the square root of b, which is negative 2. What do I do to it? Minus 4 times a. A is 1 times c, which is 17. All over 2 times a. And what's a? 1. So I get 2 plus or minus the square root of. Now remember I was calling this the radicand? I'm going to call this the discriminant now. So let's simplify the discriminant. So the discriminant is only the part that's under the radical. So what's the formula for discriminant? B squared minus 4ac. That's what this is. So let's simplify the discriminant. What's negative 2 times itself? 4. A negative times a positive is a negative. What's 4 times 17? 68? All over what? 2. So what is my discriminant? Yeah, so the value of my discriminant is a negative 64, right? Okay. All over 2. Now let's simplify this. What's the square root of negative 64?
8i.
Very good, 8i. And then I can simplify this, so that's just 2 over 2 and 8 over 2, so that's just what?
4i.
No, not 4i.
Plus or minus 8i over 2.
Say again?
Plus or minus 8i over 2.
No.
It's just 8i. Plus or minus 8i. Plus or minus
What is this answer simplified?
1. Plus or minus
1.
Oh, 1.
See what's happening, and I know what you're having in your mind. You're doing this in your mind and saying, well, those are gone. I'm only left with plus or minus 8i. You're not left with plus or minus 8i. See, and I mentioned this in last semester as well. When you cross these out, what should you put in their places? 1s. So you don't make that mistake. And also, if I cross these out, what else should I do? Into this as well, right? So all of these are all divisible by what? 2. So this should also be a what? A 4. So you got to be careful. So what you could have done, let me go ahead and rewrite this. You could have just broken it down into 2 fractions. 2 over what? 2 plus or minus 8i over what? 2, and then simplify. What's 2 over 2? What's 8 over 2? And there's your answer. And that's what this is. 1 plus or minus what? 4i over 1, which is just 1 plus or minus 4i. So the same thing. So if you tend to make that kind of mistake here, then you may want to do this. All right. Now, what kind of answer did I get? What kind of solutions did I get?
An imaginary one.
Imaginary solutions.
I was ready.
All right, imaginary solutions. Sometimes it's called complex solutions. So we have that I in there. Okay, so I want you to notice the discriminant. What was the value of the discriminant?
Negative 64.
So the value of the discriminant is negative 64. So in my mind, when I take the square root of a negative number, because that's my discriminant, right? And the discriminant is located where? Under the square root. So when I take the square root of a negative number, don't worry about the fact it's 64. when I take the square root of a negative number, what number do I end up with? An imaginary number. Okay, so if the value of the discriminant is negative, you're going to end up, you will have two imaginary solutions. So you have two imaginary solutions. And you do because one of them is 1 plus what? So there's one of them. And what's the second one? 1 minus 4i. Now, what do you remember, if you look at 1 plus 4i and 1 minus 4i, what are those? Conjugates. Okay, good. Those are conjugates. So they always end up in pairs. So if one of my solutions was 3 plus 7i, then the other one's going to be what? 3 minus 7i. So right here, not only are they two imaginary solutions, but they are complex conjugates. Complex conjugates. CONJUGATES. Complex conjugates. So if one solution is 6 plus 2i, then what's the other? Okay. So if the discriminant is negative, what kind of solutions do you get?
Imaginary.
Imaginary. How many?
2.
2, and they are complex conjugates. They're conjugates of each other. Okay. All right. Well, a while ago, we solved, I'm going to cover this for a moment. We solved this equation right here. What was the value of the discriminant for this equation? What was the value of the discriminant for this equation? Right away, tell me what it is. Someone said square root of 17, someone said 17. Which one is it? 17. Don't say the square root of 17. That's not the value of the discriminant. The discriminant is only the part that's located under the square root. It's only the radicand. So the value of the discriminant is what? 17. And if you look at your solutions, they were what kind of solutions? Well, first of all, were they real? Let me ask you this. Were they real or imaginary?
They're real.
They were real. Now, real can broke it down into rational and what? Irrational. So the discriminant is negative. I know I'm going to end up with what kind of solutions? Imaginary.
You have 2.
If it's positive, the discriminant is positive, right? They're going to be real solutions. Now I've got to determine, are they going to be rational or irrational? You know those are going to be what? Irrational. Okay. So you ask yourself, all you do is ask yourself this, is the discriminant a perfect square? No. If it's not a perfect square, then it's two irrational solutions.
If it's negative, it's going to be
Imaginary. Okay? So right here, I'm going to go ahead and rewrite this over here. So I'm going to do it here. So listen carefully. For this one, all right, let's actually work it out. Let's find the discriminant. Yeah, it is. So one of the problems on your work, she's going to say, it's not going to ask you to find what the solutions are. It's just going to say, what is the discriminant? And from there, determine how many and what kind of solutions. So first of all, let's find the discriminant. Again, you got to find A, B, and C. We know it's 17, but let's go through the process. What's A? 1. What's B?
5.
And what's C?
2.
So you still have to do that process. You still have to figure out A, B, and C. Okay, now what is the formula for the discriminant? B what? Minus 4AC. Now you just plug these numbers back in. So it's B. I'm squaring it. Minus 4 times A, which is 1 times c, which is 2. What's 5 squared?
25 minus 8.
Which is 17. So there's my discriminant. Okay, so it's positive, right? If we're negative, it would be what?
Imaginary.
Imaginary. And it would be 2 complex conjugates. This one's positive, so it's going to be real. So my solution is real. And how many real solutions are there? No. 2, because of that plus and minus. Remember that? Plus and minus the square root of 17. So if you go back, there were 2 right here. Negative 5 plus the square root of 17 over 2. What was the other? Negative 5 minus the square root of 17 over 2. So you have 2 still. You have 2 solutions. So my solutions are real. There are 2 of them. There are 2 solutions. Now you got to ask yourself, is it rational or irrational? Well, obviously you know that it's based on the problem was what? Irrational. But let's see why it's irrational. Look at your discriminant. It's 17. Is it a perfect square or not? Okay, so since it's not a perfect square, since 17 is not a perfect square, there are 2 solutions and they are irrational. Okay, so the fact that the discriminant is not a perfect square makes it irrational. And notice again, I'm going to go back to the solution. Look at these. Are these conjugates of each other? Yes. So they are conjugates. All right, and they are conjugates of each other. Okay. Now, okay, let's look at this one. Suppose we had find the discriminant. Let's suppose we had 4x squared minus 2x plus 3 equals 0. Okay, so find the discriminant. What do I need to write first? A, B, and C. What's A? What's B? What's C? 3. So the discriminant, the formula is b squared minus 4ac. What's b? In parentheses, remember, right in parentheses, what do I do to that negative 2? Minus 4 times a, what's a? Times c, right? What's negative 2 squared? Okay, a negative times a positive times a negative is a negative. 4 times 4 is 16 times 3 is 48. So my discriminant, the value of the discriminant is a negative 44. So right away, you're going to say what? So you're going to find the discriminant, then they ask you for how many and what kind. So how many solutions and what kind. All right, so how many are there? 2. So 2, and what kind are they? Imaginary. So 2 imaginary solutions. That's all you're right. Now you would also, if they asked you, you would need to recognize that they're going to be conjugates of each other. All right, next one. Same directions. Find the discriminant. Discriminant, discriminate. Find the discriminant. Let's suppose we had 2x squared plus 11x minus 6 equals 0. Okay, what's A? What's B? What's C? All right. So b squared minus 4ac. What's b? Squared minus 4 times a. A is 2, and c is -6. Our 11 times itself is 121. A negative times a positive is a negative is a positive. Okay, 4 times 2 is 8. 8 times 6 is 48. Right? So when I add them up, I get, so what's the discriminant? 169. Okay. All right, so it's positive, right? So I know I'm going to get 2 real. Now, is 169 a perfect square? Yes. So when I, remember that's the discriminant, so when I take the square root of that, I'm going to get what number? 13. So is that rational or irrational? Rational. So I'm going to get 2 solutions, and they're going to be what kind of numbers? Real, but what else? Rational. So 2 rational solutions. Yes. Yeah, and if you work it out, now remember that's all they wanted there. So if you actually solve it, so if I say then solve, let's see why you get this. So if I solve, remember here's your formula, right? Okay, what's the opposite of b? If b is 11, what does this become? Negative 11. Square root of, we already figured this out. What's this? 169. All over 2 times a, and what's a? 2. So that's negative 11, plus or minus the, oops, negative 11, plus or minus the square root of 169 over 4, right? So notice this is rational. You split it apart. Remember, that's where you break it apart. You get negative 11 plus 13 over 4, and what's the other?
So if it's negative, it's imaginary?
The square root of if the discriminant is negative, yes, because the square root of a negative number, you get that I.
Right. Okay.
So what's negative 11 plus 13? 2. So that's 2/4, which is 1/2. And what kind of number is a half? Rational. Over here, a negative 11 and negative 13 is a negative 24 over what? And what is that? Negative 6? So negative 6 is also what kind of number? Rational. So you get 2 rational solutions, and those are your rational solutions.
And can you repeat again when you split it?
When this is rational, when there's no longer a square root, when there's no longer a square root.
And you use your plus and minus. Okay, say that again. One step. You split it. Okay.
Okay.
So it's irrational if there's a square root.
If you have a square root left in it, yes. Yeah. All right. So remember, some of you are still having issues knowing what a rational and irrational number is. All right.
So can you explain the worksheet?
No, not yet. We're still in this. You know better not to ask that. Okay. Okay. Now, so we know that if the discriminant is positive, you're gonna get 2 real, right? If it's a perfect square, you're gonna get 2 what? Rational. Right here, 2 rational. If it's not a perfect square, it's 2 irrational. If the discriminant is negative, it's 2 imaginary. All right, now one other one we didn't talk about was this. What if, and I'm going to write it out right here. What if the discriminant is 0? What if the discriminant is 0? Let's look at that. So let's suppose I had some kind of equation and I did all this work, okay? So I did all this work, whatever that equation is, and I ended up with this. X equal 5 plus or minus the square root of 0 over 3, let's say. I made it up. But the discriminant is what here? 0. Well, what's the square root of 0? 0. Right? But 5 plus 0 and 5 minus 0 is still what? 5. So it's just 5 over 3. So how many solutions do you end up with? One. Now, let me quantify that. That's one, but it's a double root because this was 5 plus 0 and what? 5 minus 0. So it occurred twice as a solution. So they call it double root. So you really had one. And what kind of number is this? Rational. So you had one rational solution. But 5/3 would be considered a double root because it occurred twice. 5 plus 0 is 3. And what was the other? 5 minus 0 is 3. But it's still both 5/3. But you only list it once. You only list it once. So if the discriminant is positive, you get two solutions, real, right? If it's a perfect square, it's how many solutions? Perfect square. Two what? Rational. If it's 0, it's one rational. Just say one rational.
Okay.
One rational. If it's not a perfect square, it's 2 irrational. If it's negative, it's 2 imaginary, right? Okay, so that's your discriminant. Now on the worksheet that you had, go ahead and take out that worksheet on section 1.4. No, not 1.4, I'm sorry. 1.5. Okay, 1.5. Let me find it. Okay, take out the one that says part 2. Part 2. Okay, so let me tell you what you got to do here. So here, now what kind of equations are these? Quadratic. And remember, this one I'm sorry? Okay, this one you have to write in what form? Okay, now what does this column tell you to do? Read the directions, people. For each equation, remember the value of the discriminant. So this says value. What do I want here? The discriminant. And from there, you determine whether and the rest of these is just a check mark. So you either check it off, whatever it may be. So if my discriminant is now remember you get 2 rational is what kind of discriminant? Positive, perfect square. If it were to get 1, this had to be what? 0. To get 2 irrational, this had to be what? An imperfect. Not a perfect square. Okay? And then to get imaginary, this had to be what? Negative. Okay. The direction says this. For each equation, determine the value of the discriminant. You understand that part, right? Okay. So listen. If my discriminant is let's say 16, what would you check off? 2 rational. If my discriminant is 0, what would you check off? 1 rational. If my discriminant is, let's say, 72, what would you check off? 2 irrational. If my discriminant, let's say, is -6, what would you check off? 2 imaginary. Y'all agree? That's all that's what we just talked about. So all of this is a table just checking off whether it's 2 rational, 1 rational, and so on. So it's just using what we just talked about. Okay, what's your question?
Like for the first one, for instance, why is 16 2?
Why 16 what?
Oh, okay.
We just talked about, guys. Okay. All right. When I post the notes, I need you to go back and review those notes, okay? We just talked about all that. All right?
The sun's going down.
Okay. All right. Now, okay. Okay, what time is it? 8:10? Okay. All right, so that was the end of section 1.5. intersection 1.5.